is very low.
No, sir.
Hmm?
No, it was perfect, sir.
No, I can't hear you. So it was too low for me. Your voice is too low for me. Can someone,
No, it's okay, sir.
yeah, Tallam, Viseshta, I can't hear you. Your voice is too low for me.
Now you can hear.
Now.
Hello? Hello, sir.
Okay. Any other input so that I will raise my voice or I will check what happened to my laptop
We
or
can hear you clearly.
still, even I can't hear Angeline Rose clearly. So let
So we
me
can hear
adjust
you
my
clearly.
mic.
Sir, we can hear you, but I think you can't hear.
Okay.
You should
And
increase your volume, sir. Means
hello?
your
Nothing. Okay. Anyway, I hope even you people speak little louder and even I will raise my voice quite. Okay. So as I said again, okay. Very good evening and today we will be going to discuss week 11 and in that specifically we are going to discuss some questions which are kind of replica of graded assignment. Okay, let me share my screen and I want you guys to join this joinpd.com and yeah, just give me a minute.
Shrikant, will you be able to take questions from the previous week
Yeah,
or
see,
no?
I guess in your graded assignment there are only 8 questions,
Mhm.
so I will be taking only 4 questions today. So I hope I will complete within 1 hour or maybe even yeah, one. After that, I will take whatever the questions you have.
So I have question from week 9. So I hope once you are done with today's agenda, then we can take it up, right?
Yeah, sure, sure.
Okay,
Once I
thank
am done with today's session, I will take whatever week it may be. I will take up the questions and I will try to explain.
Sure, thank you. Okay,
Okay.
okay.
But one thing I can't hear you guys properly. It was too low. I suspect. Okay. Just can you
But
give
we
Yes.
me
can
just
hear you
1 minute? I
clearly.
will change my headphones.
Others' voice is clear, but your is low.
Huh? Hello? Yeah, I can't hear you any people. Very low. Whoever
Can
is
you
there.
rejoin? Shrikant, can you rejoin?
Hello? Bhupesh,
Sir,
you tried to
try.
speak something. Okay, anyway, just hold for 1 minute, okay? I will change my head. Okay. Now, hello?
Yes, sir. Is it audible now?
Oh my god. Sumit, I literally can't hear you.
So seems something wrong with your earplugs or
Something?
something wrong with your sir earplugs or you may rejoin and try.
Okay, let me rejoin again.
Yes, sir.
It
That
was
will be good.
too low, too low. I can't, I was literally can't hear it. Maybe my.
So try changing the audio of the
Hmm?
Zoom meeting.
Yeah, I will just check. I will just check. Just hold
And
on.
check sir desktop your PC volume settings as well if it
Yeah, right,
is
right. I will
somewhere
check.
low.
Okay, I will just rejoin, okay? I will try to rejoin again.
Yeah, sure, sir. Sure.
Hello. Hello.
Hi.
Am I audible now?
Hi.
Yeah, I can hear you now. Am I audible?
There is some.
You're audible, but with jarring voice actually.
Yeah. Voice is not clear.
Oh, so- okay. This is my third headphones I'm changing today. I don't know.
Some echo is there as well.
Yeah. So these are air dopes I am using. Maybe it will capture far noises better than the very nearer noises. So is this okay or
Now,
Yeah,
now
it's
it's
Yeah,
fine now.
better.
it's better, sir. It's better.
better?
Yeah.
Yes, sir. Much better.
Okay. Okay. Even I can hear you guys now. So yeah. Thanks. So let us start today's agenda. Yeah. Before that, how is stats 2 going on? So I have seen the results of quiz 2. We are very disappointed after seeing the results. So how was that? I would like to just take some feedback.
Sir, how was the
Yesterday, I
result?
guess.
How was the
Hmm?
result? How was the result?
It was pretty bad. Pretty. Uh, you get to know. I don't know whether yesterday there was a meeting with Andrew sir also. I don't know how
Yeah.
many of you joined that.
Yeah. We gave him like our view. Basically, we need time to practice. I think that is what we are lacking because every week new stuff coming up, so we have to like catch up uh, and
Oh
yeah.
yeah.
So, and working under the pressure of the exam within 1 hour, finishing those questions appropriately. So that is challenging because of lack of practice.
Hmm.
Actually,
Okay.
sir,
Anyway.
inflow is too high in terms of content,
Yeah.
and we are really struggling with digestion of all those contents and like. Right.
Yeah. Okay. Okay. Yeah. So. Um, okay.
Sir,
See, even in
may,
weekend. Hmm? Yeah.
may
Ashutosh.
sir, actually, what if may I ask? I know it's now it's very late now, but what if someone is not able to study 1 week and then upcoming week are coming again and again, but we are
Hmm.
lacking in previous. We are just studying previous week. So, what should be your suggestions?
My suggestion. See, when you are in a running race, make sure
Yeah.
before the race starts, make sure your lace is properly tied, your shoe is perfect.
Yeah.
Okay, we will make
Yeah.
sure right before the start itself. So once the week 1 starts, you should run, no break. That is what I observed in this many courses. Once you start running, you have no time to stop in between, take some break, and again you start run. There is no such scenario. Once you start running from week 1, you should run till week 12. You should be prepared mentally that when I am starting this course or this term,
Mhm.
there is no break. I shouldn't rest. So yeah, literally you shouldn't rest.
Yeah,
The and
actually,
that too in particular to statistics too. If you are missing 1 week, that will be definitely connecting to the next coming weeks. So that is how this structure is properly well designed. So when you
it's
are
very
in week
compact.
5,
The syllabus is too much,
yeah,
and
compact. Yeah, we are thinking of this. We are thinking to relax somehow. So yeah, we
okay.
will
So,
look into this. Hmm.
should I mean, if let's say I am at week 5 now, uh,
Hmm.
and I have exam for all the weeks, right, on
Hmm.
3rd
Hmm.
of
Hmm.
April. So,
Hmm.
what should one do? I mean, you just go for 9, 10, 11, or should we cover all the syllabus and
Not I don't say like that. Just attend these live sessions. So plan a strategy. See, there will be many strategies. See, at one
Mhm.
point in the start of week 1, you might have one strategy that every week I will be going to study some 4 hours of statistics too. I will. I will spend 4 hours on statistics too.
Yeah,
But later on, that strategy might turn into a different path. Like maybe some reasons you might not have studied enough in one particular week and you are missing, you are delaying. So then you should change your strategy. Like from 4 hours to quickly anyway complete, take 2 hours for the last week and 2 hours for this week. Kind of strategy. You should change your strategy at every point of moment. Now that we have reached till end, and if you are in between of week 5 or 6, so you should come up with a strategy so that how can you pass. So passing is our primary criteria, and next learning. Or some people might say learning rather than passing the course.
yeah, sir.
So it
Actually,
depends
yeah,
on one's own mindset.
yeah.
Okay.
So
Yeah.
actually,
So
I sometimes feel that what if I pass just the exam and don't learn the things? So I'll be facing problem in the machine learning and foundational and all subjects.
correct. See, the thing is, if you think like that, yeah, it may be reasonable for reasonable point you raise. But when personally to me, so
Yeah.
even when I'm doing my BTech or when I'm doing my masters,
Mm.
my primary intention is to not to fail in that particular course. Primary intention.
Okay.
And secondary intention will also run through, the secondary one will obviously come like I should learn some things at least. It should not be like a blind, so I'm doing this course and I forget, I don't know anything in this course. It shouldn't be like that also. So I will try to come up with a strategy to pass the course. Along passing the course, I will make some effort, right? To pass that course, I will make some effort. In that some effort, I will learn something. And after that, when I am using this particular course in machine learning or whatever you said, when I am struck at that one particular point, I will come back. I will come back to stats 2, and I will look at the what all the things required again. Then I will learn it, but clearly, or if necessary, I will learn it again by spending more time, and then I will move in machine learning. So
But
when
sir,
it
how
comes to
can
machine
you
learning,
pass without learning? Means that is contradictory.
see that is why I said that without learning, no need to learn completely.
Yeah, yeah, that I understand.
So see, what I am saying is from week one, in the start of week one, you might think that I should learn each and every lecture
Yes,
completely and perfectly.
yeah, yeah,
That
exactly.
will be our mindset. But
Right.
later on, we might miss some of lectures, and we might not understand few lectures, and
Yes,
or else we might not able to solve few questions in the
right.
previous, right?
Exactly. Yeah.
Once you are unable to do that, no need to stop there. Figure out something else. So this I'm not able to. I'm not good at this topic. Okay, am I able to proceed forward without doing this topic, or is it necessary to learn this topic? You will get to a conclusion. If not, then I will move to the week 2, and different strategy. Like I will come up now. If I am in this course and if I am in a situation that I don't know half of the things, what I will firstly think is I will try to come up with a table. So how much percentage from week 1? So I will try to ask instructors. So can I get the percentage of enter? So once I have that percentages, so I will try to get 40% at least. So I will change my plans. I will not go through all week 1 to week 11. So I will prepare in such a way that at least 60% covers perfectly. I will attend the live sessions. I will listen I will ask what all the important topics to be learned finally for end term. Maybe instructor will give or not, depends upon the instructor. So whatever he tells, I will take it, and according to that I will plan a strategy. So my preparation is not from week 1 to week 11. My preparation is something from week 1 to 4, and some parts of week 7 and 8, and some parts of week 10. So thoroughly I will prepare this. I will go to the exam and I will try to pass. Main thing, I will try to pass.
So, sir, could you please suggest some important topics or something like that in the same
We can
context?
discuss in the revision session also, right? See, the thing is, read the instructor's mind. So as we have tested you in weeks 1 to 4, 5 to 8, so usually we'll try to test you from weeks 9, 10, 11. correct? So that is the general kind of, so you try to read the instructors. So most of the topics will cover weeks 9, 10, 11 kind of thing. And also, as far as my understanding, this particular statistics to part 2 of statistics, that means week 7, 8, 9, 10, 11. These are the most important, that is the very crucial statistics kind of thing. So this is what mostly require in future also. So whatever is required, we will focus on that mainly. Correct. So this is how it will be. So don't worry. You start from week 7, 8, 9. Estimators, parameter estimators, and later hypothesis testings. So these are very interesting and not maybe interesting, but these are definitely the important topics that you have to definitely cover if you wanted to pass this course.
Okay, sir.
Okay.
Thank you.
In
Thank you, sir.
detail, yeah, in detailedly we will discuss what all the main topics you have to go through, so that you might get an idea how to prepare for end term. Okay.
Okay, sir.
Yeah.
Sure,
Okay.
sir. I'll
Having said
consider your suggestion.
everything,
Thank you.
yeah, yeah, yeah. So yeah, first and foremost thing, join this joinpd.com and type this code AWK KME. I can see 30 people join already, and the rest of the people also please join this.
Venkatesh, the revision session are still to be planned, right?
Yeah, still
They
to
are
be
not.
planned. You will,
Yeah, okay.
yeah, we will get the dates. So most probably it will be, I guess, on Tuesday or before Thursday itself. Tuesday or I don't know. Even we are planning.
Hmm.
Okay. Yeah. So I can see 108 participants in Zoom, but only 31 people joined this joinpd.com. So join this joinpd.com. I will start this and type this code AWKKME. So yeah, as I said, this is the solve with instructor session for week 11. So one thing, when we come to week 11, I strongly suggest you should be very clear or partially clear what has happened in week 10. So if you know what has happened in week 10, then week 11 you can understand it clearly. So if you are not that clear in week 10, then the same problem you will face in week 11 again. So it's just the testing we do using different tests. So in week 10 we used only Z test or Z test. In week 11 we use something called T test, something called chi-square test, and two sample test of two samples of Z test and two samples of Z test. Okay. Yeah. So how do we do? What are the statements first? What are the problem first? Depending upon the problem, we use a particular test and we try to conclude something. So yeah, let's move. So these are the instructions. Keep a notebook and pen ready for solving the problems. I will be showing you some 4 problems today. And how to join this is basically, as I'm sharing the screen, you can see you have to go through joinpd.com and enter the code AWKKME. So I hope everyone knows this. So please join this. And for every question, I will be giving you some 5 to 15 minutes, depending upon the difficulty level. So I will show the question. If you are done solving, enter the answer in joinpd.com. So you just have to enter, no need to submit or anything. And I will provide a solution and we will discuss questions and discussion and everything. Okay. Yeah. So this is a test question for everyone. So this is a very simple question or the only question, easiest question you can see in week 11. How many lectures are there in week 11 of statistics course? Okay. Just to test whether my peer deck is working perfectly or not. So whoever joined, yeah, everyone please respond. Please try to enter the answers. Okay, only 17 responses out of 41. Is this question also the hardest question in week 11? I don't know. Like how many lecture? Oh, someone said 8. 7, but seems like 700. Nice one. 11. 7. Okay, those who have said other than 7, those who have entered other than 7, you should seriously look into this, man. You should sometime open the portal at least. So, yeah. So let us move and solve the very first question for today. So in the past, it said that the standard deviation of weights of salt packages filled by a machine was 40. So we are dealing with standard deviations. Okay. So to decrease the standard deviation of these weights, a new machine is introduced. So 40 standard deviation is very high, we felt. So in order to decrease the standard deviation, a new machine is introduced. A random sample of 25 packages from the new machine showed a standard deviation of 32. Okay. Now we have a sample of 25 packages from the new machine showed a standard deviation of 32. Based on this data, what is your conclusion? At a significance level of 0.05 on the standard deviation of weights of the salt packages filled by the new machine. Okay. Now we are interested to, so I have two options for you. So what is your conclusion? Whether your conclusion is standard deviation of weights is 40 or your conclusion is standard deviation of weights is less than 40. Okay. So first and foremost thing is understand the question, and after understanding, write the null and alternate hypothesis correctly, write the test statistic correctly. Okay, write the test correctly. So these are the main things in any hypothesis testing. So you have to identify what is the null hypothesis and alternate hypothesis. After that, define a test statistic. Depending upon the test statistic, you define the test. So when to reject H0 and when to accept H0, you define the region. And once you are done with the setting, and second step is identify which test you have to use. Okay, here I wanted to compare the standard deviations. So anyway, you can see hint there. So use F inverse of chi-square 24. When you see that, you can relate, right? You should use chi-square distribution. Anyway, try solving this. Take some 5 minutes or 3 to 5 minutes time. So whatever I said, keep it in mind and solve this.
Venkatesh, sorry to interrupt.
Yeah.
Just a quick question. For the exam, these kind of questions will have the same bracket, or will you give the chi-square or the z-test options in the starting list from where we'll have to pick up? So then it will become more confusing.
See, if we have given this directly in every question, is there a
Yeah.
point of is there a point of testing you regarding which test? Will you get to know which test you have to use when it comes to, maybe you say whenever a real data is given to you, you should identify, right, which data.
No, that's
We
what I was
expect you
just
to,
checking.
yeah, we
Okay.
expect you to pick.
Okay.
Yeah. And yeah, there are 4 tests, right? So understand which test you should use anytime. See, chi-square test you use only for the positive values, right? So remember that. So if you are testing a random variable, or if you are testing for standard deviations kind of thing, standard deviations will never go negative. So usually standard deviations will relate to chi-square. Like this, you match which data, what type of data maps to what type of test. Okay. Anyway, take some 3 minutes. Maybe we can discuss at 7:30.
Sir, you started the basic guidelines. Right? Chi-square test will be used only for the positive values.
Yeah, yeah.
Why don't you give a high level guidelines for picking up the right test? I mean, it's a broad base.
See, when high level guidelines is like this only, right? That is what I said. Whenever you see standard deviation kinds of thing, whenever we are.
But how to use the other 3?
So other three, yeah. See, you use Z test and T test are very similar. So if we have given you the population standard deviation, you will use the Z test. If you have given you sample standard deviation, you should use T test. Okay, that is the difference between Z test and the T test. So that X bar minus mu by sigma by root n. So when I use sigma, which is the population standard deviation, this is Z, which is standard normal 0, 1. So if I replace that sigma with S, which is the standard deviation or sample standard deviation, that will be a T test. That will go to a T test. Like this, you should read the data first correctly. So understand whether we are testing the means or the standard deviations. If we are testing the means, what data we have given you, whether we have given you the population standard deviation or the sample standard deviation. So these are the main things. So once you understand these things, you will get to know what test you have to use correctly. Okay.
Okay. Thank you.
Yeah. Yeah. Okay. Let me give a hint to this. Okay. So let us understand. Let us start by finding what is a null hypothesis and the alternate hypothesis. So first and foremost thing is we are using in this course we are pretty much dealing with simple null. What is simple null?
Equal to comparison?
Yeah.
So H naught will be like sigma equals to 40.
Right. Our null hypothesis is like sigma is equals to 40. What is our alternate hypothesis?
Sigma less than 40.
Sigma
Less than.
Less than 40.
Someone said greater. So I guess you might read the data like this. To decrease the standard deviation of weights, a new machine is introduced. So are we trying to decrease or increase the standard deviation?
Decrease.
Decrease, right? So when we are trying to decrease, so we are trying to make our alternate hypothesis true. So always we try to make our alternate hypothesis true. So if I wanted to decrease, so I will take alternate hypothesis as sigma less than 40 and I will try to check is this true or not by the data. So if that is true, then I will reject null. If that is getting false, then I will accept null. Okay, always read the statements. Okay, read the data itself. You will get to know to decrease the standard deviation of weights, a new machine is introduced. That means I am decreasing I want sigma less than 40. I want sigma to be less than 40. So sigma less than 40 I want. Sigma is equals to 40 is the previous one. So I wanted to compare these two. So every time from the data itself you
I selected the option. How do I submit it? Automatically it will get submitted?
Yes, it will automatically submit.
Okay.
No, seems he lost his network, so probably he will rejoin.
Can anyone share the code of Yandex?
The code.
Yes. On chat box.
Hello.
Yes.
Hello. Yeah, I'm audible. Yeah, I don't know. Suddenly it will log out from Zoom. Just a second. Yeah. So where are we? So we have fixed what is null and what is alternate, right? Am I
Right.
audible? Yeah. So our next thing to be defined is what is the test statistic we use for chi-square. So what is the test statistic we use?
Basically, we have to check H0 if sample variance is greater than less than C square.
Correct. So the test statistic will be S square. Correct. Sample variance. Usually we take S square, and we know that n minus 1 times of S square by sigma square follows chi-square n minus 1. Correct. Okay, I think many of you are confusing here itself. So when we are testing the standard deviations, whether the standard deviation is equal to 40 or not or less. So these are the testing. Between these two we are testing. So in order to conclude it is less, or in order to conclude that it is equal to 40, we define a test statistic which will be equal to sample variance. So S square. So we will take T to be equal to S square. Okay, what is the sample variance here? We have.
Sir, your working is not visible. We are just stuck on the question.
No, I just shared only this. I'm not working anything.
Okay.
I'm not discussing the solution also. You should find the solution anyway. I got only 26 response. I'm giving you a hint. So your sample, your null hypothesis is sigma is equals to 40. Your alternate is sigma less than 40. This is the first step. We should know what is null and what is alternate. After knowing that, you should know what is the test statistic, and later you should know what is the test. So what test I will, so what is the test? When will I reject H0 and when will I accept H0? So after doing this, then we will proceed to the calculations. Okay. So I'm just giving you what is the test statistic, what is the test here. So what will be the test here? When we will reject H0? So if your T is equals to S square, your test static is equals to sample variance. What is the test? Reject H0. When we will reject alternate,
When greater than equal to. When S is less than C.
Correct. So we will reject H0, we will reject null if alternate becomes true. Correct? So when will alternate become true? So whenever the standard deviation is less than 40 kind of thing. So whenever I get a sample variance is less than some value, so very less than some value, I can reject null. Correct? So that means whenever my sample variance s square is less than some c square, so I reject my null. I reject null and I will conclude that the standard deviation of the new mission is less than 40, like this. Okay, usually if you see also, whenever there is less than and greater than confusions, whatever the alternate you are seeing in the alternate hypothesis, if you see sigma less than 40, your test will also be the same sign s square less than c square. So if you have sigma greater than 40 or sigma greater than some value in alternate hypothesis, even here also you will reject null if s square is greater than c. The same sign will be followed for alternate hypothesis as well as the test. Okay, you can see in many cases, see 99.99% of the cases, it will be true. Okay, now I have given you everything. Just solve for this. So solve for c value and compare s square. You have the sample standard deviation 32. So s square will be 32 square. So compare this 32 square with the c square. So if it is less than, we will reject null. If it is greater than, we will accept null. Fine. Take, oh, it's already 10 minutes done. Okay, I hope many of you done. Do you require 1 minute or let's finish this off? Shall we finish this? So I will give you more time to solve in question number 2 maybe. So once you get an idea how to solve this by looking at the solution, then it will be easier for you for the next question, I hope. So I need input. Can we proceed?
Yes, yes, please. Yeah.
Yes, sir. Yes, sir.
Yeah. Yeah. Okay. So this is how the very first step for any hypothesis testing will be find if null and alternate is not given, you should find what is the null hypothesis and what is the alternate hypothesis I am going to check. So our null will be sigma is equals to 40. Our alternate will be sigma less than 40. Now once I am done with null and alternate hypothesis, my second step is to define the test statistic. So my test statistic will be sample variance. So you can take S also, but usually we take it as a square. So you can take any test statistic, but why I am taking S square? Because I know n minus 1 times S square by sigma square will follow chi-square distribution. So knowing that when I have S square, I will just multiply n minus 1 and divide it by sigma square. I can convert it to the known distribution. So that is why I take my test statistic as t is equals to S square. So once I fix this t is equals to S square, as I said, I know that 10 minus 1 times S square by sigma square follows chi-square distribution. Here, what is n? So here a random sample of 25 packages. So my n is 25. So when I substitute 10 is equals to 25, I will get 24 times S square by sigma square. So sigma square we are testing with null. So sigma square I can put it 40. So 40 square follows chi-square n minus 1, which is 24. So this particular 24 by S 24 S square by 40 square follows chi-square 24. Now what is my test? I will reject the null hypothesis. That means rejecting null hypothesis means I will say the standard deviation of the weight of salt packets is not 40. So when can I reject it? If S square is less than C square. So I have S square with me. So S square I have. I will try to find the value of C square and I will compare S square and C square. So in order to find C square, we know that alpha is equal to, or the significance level is equals to probability of rejecting null given null is true. Correct? If null is true, sigma will be equal to 40. So I just simply substitute that. So rejecting null means rejecting h naught. When we will reject h naught, when s square is less than c square, we will reject h naught. So when probability that s square being less than c square given sigma is equals to 40. So if I take sigma value to be 40, I just multiply 24 on both sides and divide 40 square on both sides. So I will get probability of 24 s square by 40 square is less than 24 c square by 40 square will be equal to 0.05. So from here, 24 s square by 40 square is actually follows chi-square 24 distribution. Correct? So we have probability of chi-square 24 less than 24 c square by 40 square. So this particular thing I can write it as f chi-square 24 of 24 c square by 40 square. Correct? So can I write this particular thing as f chi-square 24 of 24 c square by 40 square? So it's just
Yes,
a
sir.
22 distribution, right? So once I write that, I will take that f chi-square to the right hand side. That will be f inverse of chi-square 24 0.05. So you can see we have given you f inverse of chi-square 24 of 0.05 is 13.85. Therefore 24 c square by 40 square will be 13.85. From here c square will be 1600 times 13.85 divided by 24. So if you solve this, you will get 923.33 something. So now we have c square. This particular c square is the critical value. So below this critical value, if my standard deviation, if my variance is below this critical value, then I will reject. If it is not below, then I will not reject. Right, correct? So now we have s square as 32 square. It is given in the question. So the sample standard deviation we have as 32. So s square will be 32 square, which is 1024, which is 2 to the power 10. So this particular 1024 is greater than c square, which is 923.33. Now we got s square is greater than c square. So we reject h naught if s square is less than c square. But we got s square is greater than c square. That means we cannot reject the null hypothesis. Therefore, we are not rejecting null hypothesis implies we are accepting null hypothesis. So if we accept null hypothesis says the standard deviation of weights is 40. Okay, let me check how many of you given the correct answer. Okay, very less people. Many of you gave standard deviation of weights is less than 40. Can I think it of like this? As the sample standard deviation is 32, so this particular 32 is less than 40. So we can say standard deviation of weights is less than 40. How many of you just gave that answer thinking like that? Can I? Oh, seriously? Okay. Anyway, so okay. So everyone understood how we solve this particular question? Any doubts in this?
So where I'm struggling is like when the alternate check is sigma not equal to 40. So how to attack this problem in that case?
When
alternate is sigma not equal to 40. And it's not less than or greater than, it's not equal to 40.
If it is not equal, now you see our alternate is not equal. Okay.
Yeah.
So that means 40 to the right side and 40 to the left side. So there will be some critical value. Okay, let me show you. Just a second.
Sir, it is in fact without getting into the math of the problem. Logically, the general attempt is to reduce the standard deviation. Is that right?
Right. Reduce the standard deviation.
Yeah, but you had given me an option of choosing between standard deviation is equal to 40 and other one is less than 40. So I mean, it's a no-brainer that I'll go for and choose option B. But your detailed working shows that when it is other way around.
Okay. I will tell you how to approach this kind of problem. So always our null will be very simple. Simple means it is equal to some value. But alternate changes. Alternate will be sometimes it is less than 40. Sometimes it is greater than 40. Sometimes it is not equal to 40.
Just one doubt. So this not when the situation comes is not equal to 40, because most of the problems are theoretical. So do we have to conclude that alternate hypothesis is not equal to 40? Because in this problem it is clear. It says it is decreasing. At least we can understand. So the not equal to situation, can you give some problem without mentioning?
See, as of now, with the standard deviation not equal to case, I think
it is always given directly, or
yeah, it will be given. See, in the question you can see here also we have seen that the standard deviation is 40, and alternatively, alternatively what we are trying to do is to decrease. Alternatively, we are trying to decrease.
Yeah.
So that is what it says. But whenever the statement is like this, so I suspect that it is not equal to 40, or I suspect it is different from 40, kind of thing. If the statement is like this.
Okay. So
in that case, that will be sigma not equal to 40.
Okay.
Okay. Yeah.
But
see,
sigma not equal to 40. Be either one of the two alternatives what we are having it. No? Is there another one without?
This is different.
Less than 40 and greater than 40, leaving that one, anything else is there?
That's it. These are the three cases we have.
No, third case is still not able to really align.
Okay. Okay. First and second is clear, right? See.
First and second is clear.
Sigma can be sigma is a random variable and it can follow any distribution. So what we are doing, what we are checking is, we are checking this sigma is equals to 42. There is some critical value, C. If my sigma is below this, if my sigma is far below this, that means we can conclude that sigma is not equal to, or sigma is less than 40. So I can conclude this. I am concluding this means my alternate is true, and I am rejecting null. So in this region, we reject null. So if my sigma goes very less than some value C, which is the critical value, I will reject my null, saying this particular sigma doesn't even come anywhere near to 40. So I will conclude that sigma is less than 40. So there alternate is true. Below this particular region, alternate is true, and we reject H0. And even here also, after some value, critical value C, if my sigma is beyond that particular C, what I will do is I will reject H0, saying I am accepting null, saying that my particular sample's standard deviation is far greater than some particular critical value. So depending upon this, I conclude that my standard deviation will nowhere near to my sigma is equal to 40. It is far greater than 40, and I will accept null in this region. So in this particular region, what happens is I'm not that sure that I should reject null. So that is what it happens in this particular region. So in this region, if my sigma falls in this region, what I conclude is, see, sometimes this particular sigma is very nearer to 40. I'm not sure whether I can actually accept alternative hypothesis. So what I do is, anyway I have a null hypothesis, or anyway I have this null, right? So we will accept that null. So that is how we conclude. So if my sigma is falling around this region, we will conclude like this. So I'm accepting null means already someone did some statistics and they have come up with, someone has done many samples and checked and given me that sigma is 40. So even my sample standard deviation is somewhere nearer to 40. I don't want to bother them or something like that, and we will accept that null. So that is what it happens. But if it is far greater than, so if it is far greater than, then I will bring that sample and I will show to them. And I will say, you said sigma is equals to 40, but this is far greater than 40. So I am contradicting your statement that sigma is equals to 40. This is how we call it contradict, and we will accept nulls. So in this case, it is okay. But when it comes to this particular case, sigma is equals to 40 and sigma not equal to 40. In this case, my testing is very simple actually when it compared to both. Here what happens is, if my sigma goes above or below after some critical value, so if I say this is the critical value, if it goes far greater than some value, also if it goes far below than some particular value, here also I can conclude that sigma not equal to 40. Here also I can conclude that sigma is not equal to 40. So the region will be bigger to reject. No. So this is the region. Combination of this plus this is sigma not equal to 40. Okay. So in this case, what should be the test is? Okay, my test statistic should be something like, let's say, s square. So my test should be, I will reject h naught if mod s square minus 40 is greater than some value. So this particular difference on both sides. So this is 40 and I will get some s square. So that particular difference should not be greater than some value. So if it is mod of that thing should not be greater than particular value. So even if it is, so I say not even, don't bring mod again. Reject h naught if s square is less than minus c square or s square is greater than c square. Okay. So this is how I should reject. So even I go far below some value. So this is okay, c square. Let's say c square. Everything is c square.
So maybe s square not equal to c square.
S square
not equal to c square.
No. That is what I said, right? We don't exactly get the standard deviation value, right?
Yeah.
Population standard deviation, we don't get the sample deviation to be exact.
Okay.
But if my sample is very nearer to the value 40, I cannot reject. I cannot actually reject. See, that is what you said. See, okay, let's think it of like this. So I say Bhuvneshwar Kumar bowls at an average speed of 135 from his past bowling.
Still again, the third case is a redundant case on case 1 and 2, no?
Yeah, case 1 and 2, but this is slightly, the rejection region will be slightly higher.
Does it really matter? Because if you are rejecting the case in either on option 1 or 2, obviously it is closed case. Is it? Why do we go to the third case in a situation where already one is finalized? Am I clear in my question?
Can you ask it again?
No. See, the hypothesis is decided based either on case 1 or 2, and case 3 is nothing but a combination of 1 and 2.
Yeah.
So if I am rejecting the hypothesis based on either case 1 or 2, still the case 3 is not going to change the result.
Yeah. See, that is correct, right? The combination of case 1 and case 2 is case 3.
Yeah.
But here what you have to do is you have to that is the same thing. You can reject if s square is less than some minus c square, you will reject, or if s square is greater than c square, you will reject. That means if s square is less than some particular value, you are going to reject. If s square is greater than c square, you are going to reject. It's just a combination of case 1 and case 2. But the way we deal with this is nothing but you are dealing case 1 and case 2 at the same time. Okay, so okay. Let me tell you. In this particular case, if my S square is something like 57.27, okay. If my S square is 57.2 whole square. So will you reject null or will you accept null?
S square is
S square is 57.27 whole square, and definitely your C square, what you are going to get is predominantly less than 40 only. So your C square is below 40. So let's say 40 square. So your C square will be below 40 square. So this particular S square will be greater. So what I say is your S square means this particular sample value is falling in this region. So if my sample is in this region, sample value is in this region, it is not in the rejection region. Correct?
yeah.
Am I correct? C.
Yes, yeah, we understood.
Yeah. So the thing is, this is C. So below this C, C square, let's say C square, below this C square, I will reject null.
Right.
Above this C square, I accept null. So this
Yeah.
is my accepting region. So if my S square falls in here, so let's suppose S square is here and
Yeah.
sigma square is here. So will I accept null or will I reject null?
Accept it.
Accept null, right?
Yeah.
But the same thing when it comes to here, when S square is 57.27 something, that particular S square might fall in this region here and I will reject null.
Right.
Okay. So depending upon alternative, I decide whether I should accept this particular sample variance as whether I should accept null or whether I reject null. So depending upon the alternative, I will decide.
One query, sir, like you mentioned in column, you mentioned minus C square, whereas in first column you mentioned C square.
See, that is it is anyway anything.
It's minus. Okay.
Some particular D square. Let's say no need to bring some particular D square. Okay. So if it is less than some D square or if it is greater than some C square, we will reject. So the acceptance region is very small here. Very small.
Okay.
Okay. So depending upon the alternative, in this alternative hypothesis, if I get 57.27 something, this particular 57.27 something is greater than C square. If I got like this, I will reject null and say my sigma is not equal to 40 and I accept alternative. But when it comes to case 1, I am actually accepting null, saying that sigma is equals to 40. Okay. So yeah, treat it like, see, case combination of case 1 plus case 2 is case 3. I agree. But not always. Once you are, it may be different. If you are accepting null in case 1, you may reject the same null in case 3. Same goes with case 2 and case 3 also. In case 3 also, you might reject null, you might accept null, but when it comes to case 3, you might reject null. For the same test static values, for the same S square and S square value, you might reject, accept. So depending upon alternative, we decide. And that is how this test will vary for every alternative. So this test is different for all the cases. Here the test is reject H naught if S square is less than some C square. Here it is reject H naught if S square is greater than C square. You see this greater than, this less than, less than. Here sigma not equal to 40, that means sigma less than 40 or sigma greater than 40 or both the cases. So that means S square less than D square I reject, S square some greater than some C square. So some values. Okay. Yeah, see, solve few examples, solve few questions, you will get a better idea. And don't worry about not equal to case that much. So even we are not interested to deal these type of cases. Okay. Do worry about case 1 and case 2 kind of things. Okay, let's move. Let's move. It's getting delayed. Okay. Now I have another question. This question is a sociologist focusing on popular culture and media believes that the average number of hours per week spent on social media is different for men and women. So now that we are having two different sets or samples, two different sets, men's set and women's set, the researcher knows that the standard deviations of amount of time spent on social media are 8 hours per week and 10 hours per week for men and women respectively. Okay. Now examining two independent random samples of 100 individuals, each if the average number of hours per week spent on social media for the sample of men is 3 hours greater than that for the sample of women, what conclusion can be made from a hypothesis test? Okay, so what we will do, will we reject null or will we accept null? So null and alternate are given to us. So null is mu m is equals to mu w. Mu m is the average, let's say mean is nothing but the average amount of time spent on social media. So that is nothing but the mean of men's sample. So mu w is mean of women's sample. So what my test is, I am testing whether both the means are equal against the alternative both the means are not equal. Okay. So my significance level I am testing at alpha is equals to 0.01. And also we have given you F inverse of Z of 0.005 as minus 2.57. Okay. Yeah, first tell me what is your test statistic? What is your T?
Before that, I have one doubt in the question itself. The question says the media believes that average number of hours spent on social media is different for men and women. So will it not
It believes.
Null hypothesis is different? I mean, mu m and not that should be the null hypothesis, right?
No. See, they are believing that it is different and they started the research. So their belief will fall in the alternative.
Oh, okay. That is really tough challenge, actually. This is what we all, I think, very difficult because I thought whatever given that we should take as a null hypothesis. Okay.
No, it is not given. They are believing that it is true and they have the researcher knows. They started examining. Yeah.
Okay.
See, and also we said it
In the
directly, right? We always take null to be simple null.
Oh, okay.
Yeah. Yeah, my question is, what is the test statistic here? Is it mean of men? Is it mean of women?
It's both mean of men and women, right? Two sample.
Yeah, two samples, but test statistic will be single test statistic, right? So what is
Difference
the
between the both means. Mean of
difference between both means? Correct. So difference between both means is the test statistic. So identify the test. So when you will reject H naught. So once you identify the test, I guess pretty calculation, heavy calculation you should do, and you will come to a conclusion. Okay. Here, what is the test we follow? When do we reject null? So what is the test here? We reject null
if mod t greater than c.
Yeah. So do you understand why mod t? Mod
Because we are taking not equal to, so we will consider both sides of.
correct.
Okay.
Correct. Both sides. Yeah. So what we are doing here is we are trying to find the sample average number of hours spent on social media for men, which is X bar, let's say X bar, and average number of hours spent on social media for the sample of women, let's say Y bar. So what we are trying to come up with is we see the difference between these two. We are trying to see the difference between these two, and this difference, if it is very less, very small value, then we say the mean X bar and Y bar are pretty much same, and we conclude that mu m is equals to mu w. So if this difference is more, so when I say difference, X bar minus Y bar, or it can be Y bar minus X bar. Both ways, if the difference is more than some critical value, which is C, then we will reject, saying that the average number of hours spent on social media for men and women are different. So that is why our test statistic should be the difference between the means. And if this particular difference, mod of this difference is greater than some critical value, I will reject null. If it is in between the critical value, I will accept null. That's it. Now the test is reject H0 if X mod of X bar minus Y bar greater than some C. So using this, try to find, yeah, before this, X bar minus Y bar is a random sample, random variable. And how does it follow? What is the distribution it follows? If these are normal, X and Y are normal, how will X bar minus Y bar random variable? What is the distribution of X bar minus Y bar random variable? So if I say
That will
T
be
is
also
equals to X,
normal.
yeah,
That is
it will
also
also
normal.
be
Linear
normal.
combination. Yeah.
Yeah, with
Linear
mean.
combination. Yeah.
So what is the mean and standard deviation? Okay, let's see. Let's discuss. Okay, I got only 10 responses. And even the 7 people accepting H note and 5 people rejecting H note. Okay, let's see. So we follow stepwise procedure. First and foremost thing is we have null and alternative here. So we need the setup. So let's say Xi and Yi represent the average number of hours spent on social media by men and women respectively. So each Xi is the average number of hours spent on social media by some ith men. So we have asked 100 men, and we have tested 100 men. So X1 represents the average number of hours spent on social media by first person. Likewise, second person is X2, X3, and X100 is the average number of hours per week spent on social media by the 100 men. Similarly, so we know that this particular X1, X2 are all IIDs of normal with mean mu1 I have written, but it is mu of m, comma. It is given, standard deviations are given. You have to identify the researcher knows that the standard deviation of amount of time spent on social media are 8 hours per week and 10 hours per week for men and women respectively. So we know the standard deviations of X and Y. So standard deviation of X is 8. So variance will be 8 square. Similarly, we have tested for 100 women also, which will be Y1, Y2, Y3 and so on, Y100. So these are all random variables which follow IID normal, mu W or mu2, comma 10 square. 10 square.
how do we conclude that this is normal distribution? It is not
Yeah,
given.
usually in the lectures also we have taken, right, more than 25 samples. We usually tend to, if I have taken more than 25 samples, you can actually, whatever the distribution may be, CLT.
Okay, so we can say, okay.
Yeah, by CLT we can actually take it as a normal distribution. It follows normal. Okay. Yeah, from there, see, usually in this week also, whatever the samples we take, usually it follows normal. So we haven't used, unless and until it is other distribution, there is no need of mentioning it. So if it is, we are taking from different distributions, we will definitely mention that these are IIDs of some Poisson or geometric orbit. Okay, yeah, let's come back. So we have tested 100 samples of men, 100 samples of women, which are x1 to x100 and y1 to y100. This follows x1, x2, x100 follows normal mu1 comma 8 square. y1, y2, y100 follows normal mu2 comma 10 square. Now it is also given that x bar minus y bar is 3. So I have used mod also, it doesn't change. So x bar minus y bar, that means the amount of average number of hours per week spent on social media by men is 3 hours more than the average number of hours per week spent on social media by women. So the difference is 3. So we need to find that particular C critical value and we will compare that with this difference. Okay. If this difference is more than the critical value, we will reject null. If the difference is less than this particular value, 3 is less than the critical value C, which we are going to get, then we will accept null. So that is, so this setup you have to make, and later we will consider the null and alternate. So null is mu1 is equals to mu2, alternate is mu1 not equal to mu2. Now our test statistic is x bar minus y bar. So this x bar minus y bar follows normal. So it is a linear combination of two normal distributions. So see, x bar is actually a linear combination of 100 normal samples. And similarly, y bar is a linear combination of 100 normal samples. So therefore, x bar minus y bar is actually a linear combination of 200 samples. Correct? 200 normal samples. So this particular t also a linear combination of normal. So if it is linear combination of normal, it will follow normal mu1 minus mu2. You can check expected value will be mu1 minus mu2, comma. The standard deviation will be sigma 1 square by n plus sigma 2 square by n. So sigma 1 square is 64, sigma 2 square is 100. So 64 by 100 is the number of samples, n1, plus sigma 2 square by n2, n1 and n2 are 100. So if I compute this, I will get 164 by 100. Now my test is reject H0 if this difference is greater than some critical value. If this difference is more than some critical value, what we get is, we are getting that the X bar, which is the average number of hours spent on social media by men, and Y bar, which is average number of hours spent per week spent on social media by women. This particular difference is more. If this particular difference is more, that means this X bar and Y bar are different. Or these are not equal. These are not very nearer. That means I can conclude that this particular mu1 is not equal to mu2. That means my alternate will become true. Therefore, I will reject H0. So that is how we come up with the test. So we reject H0 if mod T is greater than some critical value. Okay. Yeah, once I fix this test, now I have to find the value of alpha. So alpha is nothing but equal to probability of, we reject H0 given null is true. So reject H0 means mod T greater than C. So null becoming true means sigma 1 is equal to sigma 2. So when sigma 1 is equals to mu1 is equals to mu2. So when mu1 becomes mu1 is equals to mu2, this particular test statistic follows normal 0 comma 164 by 100. Right? When mu1 is equals to mu2, this becomes 0. So mean of test statistic becomes 0. So therefore what we do is we subtract 0. So mod inside t minus 0 divided by root over sigma square by n. Okay. So variance is 164 by 100. So root over variance, we require standard deviation. So root sigma. So mod t minus mu by root sigma. So converts to standard normal. So when I subtract 0 and divide it by root 164 by 100, same thing I should do on the right side also. So c minus 0 divided by root over 164 by 100. So this becomes, this particular mod t by root 164 by 100 becomes mod z. So z inside thing will be following standard normal. So this becomes probability that mod z is greater than c by root 164 by 100. So this is nothing but we have many ways to do. So this is nothing but z less than minus c by root 164 by 100 plus probability that z greater than c by root over 164 by 100. So you can convert and interchange, and finally you will get 2 times of fz minus c by root over 164 by 100. So this is easy conversion, I guess. Hope everyone understand this. Yes, no?
Yes, sir.
From this step to this
Yes, we
step
understood.
is yeah.
Yeah,
So once
it's
we
many
get
problems.
this, someone, what is
Yeah,
the
we
last statement?
it's many problems we have crossed this. Yeah.
Okay, yeah. So we have seen this in many problems. So this will be 2 times of fz of minus c by root over 164 by 100. So now interchanging this, so bring the 2 to the left hand side and this fz to the left hand side. So we will be getting, bring this root over 164 by 100 to the left hand side and make c on one side and remaining everything on the other side. We will get c is equals to minus root over 164 by 100 f inverse z of alpha by 2. So we have taken sigma significance level to be 0.01. After substituting we get this. So solving this, substitute the value of f inverse of z 0.005 we have given you as minus 2.57. So solving this we get, ultimately we get 3.29. So C value, critical value is some 3.29. What this tells is, so we accept null if my difference is somewhere 3.29. If my difference is between 3.29, 0 to 3.29, what I will conclude is the average mean of men and mean of women are equal. So up to this 3.29, I can say mean of men is equals to mean of women. So if my difference is more than 3.29, that means this is the critical value. We tolerate this much value. Yeah, so what we say is we will tolerate till 3.29. That means if the average number of hours spent by men is somewhere around 7, that means we will tolerate, or we will say it is equal if it is the average number of hours spent by women is either 4 till 4 or not till 4, 7 minus 3.29 or 7 plus 3.29. So the average can be in between any of these values. So we will accept saying that 7 and 8, if it is like 7 and 8, mean is 7 for men and mean is 8 for women. We say that it is pretty much nearer, so we will accept it. We will accept that both men and women are spending the same time. Like this. So we will tolerate till the difference is less than or equal to 3.29. If it is greater than 3.29, we will reject them. So we got mod x bar minus y bar as equal to 3, which is inside the region, inside this critical region. So 3 is less than 3.29. What we conclude is, so yeah, difference 3 doesn't guarantee us that averages of men and women are different. So we say averages are same only. So that means saying this statement same averages, we say that we will accept null. So accepting null is nothing but we are saying that the average number of hours spent by men on social media is equal to average number of hours per week spent by women. So that is how we will accept. That is why we will accept null. Because the test statistic is less than C, value C. So mod T greater than C we will reject. Mod T less than C we will accept. So here mod T is less than C, so we will accept. Okay. Yeah. So now this is another question. The manufacturer of a new car claims that a typical car gets a mileage of 36 kilometers per liter. Okay, he claims. Now we think that the mileage is less. Okay, claims that it is 36 kilometers per hour per liter. Now we think that the mileage is less. To test our suspicion, we perform the hypothesis test with null mu is equal to 36 with alternate mu less than 36. Suppose we take a random sample of 100 new cars and find that their average mileage is 36.4 kilometers per liter and sample standard deviation. See, the sample standard deviation is 4. So we have given you the sample standard deviation. From this, we know that we have to use t-test. So what does a t-test say about a null hypothesis with a significance level of 0.05? So will you accept null or will you reject null? Okay, this is a pretty straightforward thing. So we have given you the null, we have given you the alternate, and we have given you the number of random samples we tested, and we know the mean of the random sample. We know the sample standard deviation. So identify the test statistic and identify the test we are performing and check whether my test statistic falls in the rejection region or accepting region. Okay, take some.
Yeah, one doubt actually, if your data is not given for null and alternate, so can we take can we use a claim as a hint for null, or we can't do that?
Yeah, you can do that. See, when we say it is equal to something, so that is null.
No, here it is given. If it is not given, so like your data is not given. So when in that case in exams, so can we always take when something says claim, can we take that as a hint for null hypothesis?
Correct.
And
you
then
can take.
Okay, because it's very challenging. Only the first part. Rest is everywhere it's same, but the first part is such a challenging one. Which one to take as a null and alternate hypothesis?
Okay. Yeah. See, you will see two different statements in the question. So one is the first statement may be anything, and the second statement
You are not
either of the statement.
audible.
Am I not audible?
No, you are audible.
You are going very far away from the speaker.
Okay.
Right.
Okay. See, there will be two statements. So one statement refers to null and one statement refers to alternate. So either of the statement you will see words like less or small or what are the synonyms of less, small, lesser or greater, larger, not equal. These kind of words you will see either in one of the statements. When you see those statements, those particular statements refers to alternative. Here also you see we think that the mileage is less. Okay, this cannot be null. Okay.
Because
So once this is not null.
Okay. Yeah. The previous problem, it was very difficult to have the null. It was difficult to. That's why.
Okay. Yeah. in these type of places, when we say claims and it is referring to one particular value, then that will definitely be the null.
Okay. Yeah.
Okay. Okay, try this. This is similar to week 10 kind of problems, but here we have given you the sample standard deviation, not the population standard deviation. Same method you should follow. Identify test statistic, test, and follow the test by taking the significance. Yeah, everyone try this. This can be solvable in 2 to 3 minutes, I guess. So try solving this and try to submit the answers. If you are unable to solve, try making sharp guesses at least, like by looking at the question. Okay, are people trying to solve? Do you guys require time or?
Just one more minute.
Yeah, sure. Please solve. Okay, try to solve. So unless you keep pen on the paper, you will not be able to understand how we are solving these things. Okay. Yeah, I will let someone to explain this. Can someone explain the solution for this? Anyone? No one.
I have got the success. I don't know whether the answer is correct. Is it correct?
Yes,
Okay. Just let me know the procedure. Don't worry about the answer. If your procedure is correct, you will eventually end up getting correct.
Someone was trying.
yes,
Yeah,
sir.
I will. Ayush, yeah.
Yes, sir. Statics test will be T less than C.
Okay. Okay, T less than C. What is T? What is your test statistic?
Yeah,
What is T? T is equals to, what is the test statistic you took?
mu is
Hello?
yes, sir. Yeah, mu is smaller than C.
No, I'm not talking about the test. I'm talking about the test statistic, which is T. What is T? So T is equals to S square, or T is equals to X bar, or the sample mean, or T is equals to something X1 plus X3 plus X5 plus and so on, the odd values, odd random samples, or
Yes, sir.
what
T
is?
is for X bar. X bar.
Yeah, okay, X bar. Now, when you have X bar with you, how do you convert this X bar to some well-known distribution? What is your well-known distribution? So you
Sigma
have
square.
Okay.
Yeah,
Continue.
T actually, sir. T is smaller than C. Then T minus mu, it means that 36 by S by S here is 4 root under 100. Smaller than C minus 36 by 4 root under 100.
Okay. Yeah, correct. So why we are doing this X bar minus 36 by 4 by root 100? So why we are converting that? So
To
why not
convert
it
in
is left?
to convert in a standard T n minus 1 distribution.
Correct. Right. So from there, we will find the value of C. So what is the value of C you got?
335.336.
So you got C value
C
as
square 5.336.
Correct. So once you got that, so what we will compare? We will compare it with?
Yes, sample X bar. I compared with X bar.
Yeah, sample mean. So our sample mean is 36.4.
36.4.
So this is greater than 35.33.
It means we.
It means what we will do? Will we accept null or will we reject null?
Accept null.
Correct. Yeah, pretty much same. So we have given you the significance level as 0.05. We know the sample mean is also given as 36.4 it should be. Okay, my bad. So here null hypothesis is given to be mu is equal to 36. Alternate hypothesis is mu less than 36. Here the test statistic is X bar. So the test will be reject H naught if my test statistic is less than some value C. So we are checking the left tail. So yeah, so once we know this test statistic, test and null and alternate, we know that, yeah, in this problem we do not know the population variance, correct? We know the sample variance. So we can use T test, not the Z test. So in order to use T test, if I have a random variable X bar, so that X bar minus mu by S by root n gives me the T distribution, Tn minus 1 distribution. So in order to convert that, I will use this So yeah, I will use that particular conversion in this. Alpha is equals to probability that we reject null given null is true. So null is true means mu is 36. So the mean is 36 now. So therefore alpha will be equal to probability of x bar minus 36 divided by root over s square is less than the same operations we will do on the right side. C minus 36 by root over s square by n. So whatever you are seeing here, this x bar minus 36 by root over s square by n, this is a t distribution with Tn minus 1 distribution. So this follows Tn minus 1 distribution. So we know s square is 16. So substitute that. So we'll get like this. And from this, you see, this is a T distribution. So T99. So we have n is equals to 100. So this will be T99. T99 less than C minus 36 by root over 16 by 100. So this will be F T99 of C minus 36 by root over 16 by 100. So therefore alpha will be equal to ft99 of c minus 36 by root over 16 by 100. From here, just substitute the value of alpha. Just rearrange, bring c to the one side and everything else to the other side. We will get c is equal to 36 plus root over 16 by 100 times f inverse of t99 of 0.05. So if we solve this, we will get c is equal to 35.336. So since we have x bar as 36.4, which is greater than 35.336, we accept null. So t is greater than c here. So if t is less than c, we will reject null. Now we got x bar is greater than c, so we accept null. So the same approach, have you observed or not? From the right from the question 1, 2 and 3, we are following the same approach, but the way we convert this random variable to the well-known distribution is different. And this particular test and test statistic is different. So the main key for any hypothesis testing problems is to identify this test statistic, to identify this particular test, this null alternative. Anyway, you have to identify these things. Most of the cases we will give you. If not given also, you have to identify this. After that test statistic, you have to identify the test. When will be test region, rejection region. So after this, you have to convert the test statistic into the well-known distribution. So well-known distribution you have to convert. After converting that, it's a matter of calculation. If my randoms, if my whatever the value I have, test statistic value I have, if I will compare that test statistic to this critical value, and I will decide whether to accept null or to reject null. Okay. Yeah. So this is another question I have here. So an IITM instructor conducts 2 live sessions for 2 different classes. Call it A and B in statistics. Session A had 25 students attending, while session B had 50 students. The instructor conducted a test for the 2 sessions. Although there was no significant difference in mean grades, session A had a standard deviation of 12, while session B had a standard deviation of 15. Can we conclude at the 0.05 level of significance that the variability is nothing but the variance or the standard deviation in marks of class B is greater than of A? So can we conclude that this statement is true? Can I conclude that variability in marks of class B is greater than that of A? Okay. So now we are comparing the standard deviations, not the means. So now the distribution changes. So till now this Z test, T test and this chi-square test, we tested it on sample means. Now we are testing it on standard deviations. So testing in standard deviations, we use F distribution. Correct? Am I correct? Oh, am I audible?
Yes. Actually, I don't
Yes,
know.
right. So okay. Now, am I correct?
Variance, yeah, variance we use chi-square also, so it's just confusing where to use F-test. That's why.
Variance we use? For variance we use?
Chi-square also, right? Variance.
Chi-square. Yeah, chi-square. See, the thing is, for variance, we use chi-square only for one sample. If I have only one sample,
okay,
and if I am testing that sample standard deviation,
this is
we will
ratio
use
of 2.
chi-square.
Okay.
Yeah, this is between two different samples. Between two different samples, we use F distribution.
Okay.
Okay. Try solving this. Okay, tell me what is the null and what is the alternative version? Hello?
Null here is sigma A minus sigma B is 0.
Yeah, sigma A. It is nothing but saying sigma A is equals to sigma B.
Yeah, and alternate hypothesis will be taking sigma B minus sigma A is greater than 0. And we only need to check the right tail, so we'll be taking alpha is equal to probability that test statistic, that is the ratio of their variances, is greater than 1 plus CR.
Correct.
From there, we'll get 1 plus CR is 1.85.
Okay. That is correct. Okay, let other people also try solving this. We will discuss the solution at 8:50. So you have 2 minutes. Okay, still trying.
Yes, sir. A minute more, please.
Okay, sure. Is Apple here? Apple?
Yes, I'm here, Venkatesh. I'm here.
Yeah. So may I know what is the difficulty in week 9 you have pointed out, right?
Yes. So what is happening is I'm going through the formulas in terms of understanding the distributions, and I'm unable to relate the conversion of lambda, which perhaps is given in the question, and the solution to the problems which is in the tutorials. So that is where I'm facing some problem.
Okay.
And specifically, I can tell you the question also, tutorial 1, question 5.
Tutorial 1, question 5.
Yeah.
Okay, let me open that.
Yeah.
We will discuss that question, okay? Okay, I just opened this. Consider x1 to xn IID Poisson lambda with prior gamma alpha beta. I suppose that is the question.
Yes. So what is happening is you can open the solution also. The way solution has been written and the way the formulas are written in our file.
Okay.
Right. So that conversion is what I'm facing problem with, because over there in the formula it's written x, and in the solution we have taken it as lambda. So that conversion or that interpretation is where I'm facing a bit of challenge.
Okay. Okay, we will see. Let us complete this solution
Yes,
and let me
exactly
try to.
right. Even I'm trying this only. Thanks.
Yeah, try. Okay, we will see. We will see the solution for this. So what we have given you is, we have given you two different sets. One is set A and set B. So set A or session A, there are 25 students, and among the 25 students, we have conducted an exam, and in that exam, the standard deviation of the marks is 12, and in the session B, the standard deviation of marks is 50. But in session B, there are 50 students. Now, my question is, at the significance level of 0.05, can I conclude that the marks distribution between the students in class B is greater than that of A? That means the variability is greater than that of A. So my null is sigma 1. Okay, let us say sigma 1 is the standard deviation of session A, and sigma 2 be the standard deviation of session B. So I know that my null is sigma 1 is equals to sigma 2, because usually this will be null hypothesis will always be simple. So we are checking whether the standard deviation, whether the marks distribution among the students in both the sessions are equal, with the alternate hypothesis that session A has less variability than the session B. That means alternative is sigma 1 less than sigma 2. So we are checking with this, and my test will be, I will reject H naught if the sample variance of B of the of B of the second set B, if my sample variance with dividing with sample variance of A. So when I divide this, if it is greater than 1 plus CR, some CR is some value, critical value. So if it is greater than 1 plus CR, so understand this, if it is equal to, or if it is equal to 1, S square by B by S square by A is equal to 1, that means S square B is equal to S square A. That means both the sample variances are equal. So if I am saying that the ratio is greater than 1 plus some critical value, that means the ratio is, the upper value S square B is greater than S square A, SEA square, sorry. So the sample variance of set A, random sample A, set A is lesser than, if it is lesser than sample variance of the set B, then I will reject H naught. Saying that rejecting H naught means accepting alternative. So accept alternative means I am claiming that the variability in session B is greater than the variability in session A. So this is how the set test will be formed. So we will reject H naught if SB square divided by SA square is greater than 1 plus CR. Now we know that S square B by SB square by SA square follows F distribution.
Sir,
F
hello.
of yeah.
Sir, I have a doubt here. Like here it is written that test statistics as S square B divided by S square A. So supposedly, if I want to write it like S square A divided by S square B, then we should reject H0 if that thing should be less than 1 minus CL. Would that be correct?
Correct.
Okay. Oh.
See, even you can do like that also, but the thing is, whatever we gave you, the information, it should also be helpful to you, right? So we have given you the F inverse of 0.95. Okay. If you want to get this 0.95 value, you should use this thing, 1 plus CR thing. Okay. So this greater than is important in your alpha. Alpha is equals to probability that I will reject this. I will let you know. See, this particular SB square by SA square follows F n2 minus 1 by comma n1 minus 1. So here n1 is 25, n2 is 50. So just substitute the values of n1 and n2. We get that this particular random variable SB square by SA square follows F of 49 comma 24 distribution. So once I know this, so I know alpha is equal to probability of rejecting H naught given null is true. Correct? Now test statistic is T is equals to SB square by SCA square. Now my T follows F of 49 comma 24 distribution. Now my alpha is probability that I will reject H naught given H naught is true. That means probability that T greater than 1 plus CR given sigma 1 is equal to sigma 2. Now this particular probability, I can rewrite it as 1 minus probability of T less than 1 plus CR. Now again, this probability that T less than 1 plus CR. So this T is nothing but following F distribution, F of 49 comma 24 distribution. So I can write it as alpha is equals to 1 minus F of 49 comma 24 of 1 plus CR. Now rearranging and bringing 1 plus CR to the left hand side, we get, now you see here, here we have 1 minus alpha now. F inverse of F of 49 comma 24 of 1 minus alpha. So this 1 minus alpha is equal to 0.95. So if you have taken in your way, like you reject null if SA square by SB square is less than 1 minus CL, then this should be like probability that T less than 1 minus CL. This will become F of F24 comma 49 of 1 minus CL. Directly it will become F of alpha will be equal to, you will not get this, F of F24 comma 49 of 1 minus CL. So you will get F inverse of F of 24 comma 49 of alpha, which is 0.05. That value you don't know, right?
Yes,
You
sir.
don't know the
That is
value of
yes.
F in, yeah, there you will start. So whatever the
Oh,
information we gave you, you have to use that particular.
okay,
So
sir.
this 1 plus, yeah, this 1 plus CR will be equal to the F inverse of F of 49 comma 24 of 0.95. So this value we have given you as 1.86. So now we have a 1 plus CR value as 1.86. Now we have to check whether my test statistic, which is SB square by SCA square, the value of SB square by SCA square. So SB square by SCA square, I know the standard deviation of sample B and sample A as 15 and 12. 15 square by 12 square will give me somewhere around 1.5625. So now that my test statistic is less than 1 plus ER, I reject. Sorry, I accept null. So if my test statistic T is greater than 1 plus CR, then I will reject. But here it is less than 1 plus CR. My test statistic T is less than 1 plus CR. So I will accept null. So I am accepting null means the variability in marks of class B is not greater than of A. Yeah, it is same as saying the variability in marks of class B is equal to that of class A. So we are accepting null. Null says both the standard deviations are equal. So both the variabilities are equal. So that is what we can conclude. So we cannot conclude that class B has a higher variability than the class B. That is not, that we cannot conclude. We can conclude that class B and class A has the same variability. So answer to this should be no. But most of you have given yes. So recheck this. So follow this. I will try to upload the slides also. So go back again and check this. Okay. So I have discussed, I guess, 5 questions out of 8 questions you have. So the first question is actually 2 questions. So you have to identify the null is 1 question and solving is another question. Yeah.
So here my question might sound some silly, but the thing is that okay, we are able to calculate later on the things, but how to decide that which test is going to be applied over there? Like over here we applied the F test. Previously we applied the T test. Somewhere we applied the Z test, right? So on the basis of the problem statement, how to if hint is not given, right? You seeing that hint, we can say okay, over F test need to be applied over there, so we can go like that. But if hint is not available in that particular question, then how to decide that which test to be applied?
Okay, as I said earlier also. So if you are testing sample means, okay, I will give you in detail, somewhat in detail, like a table. Okay. So if I am testing mean value. So these are three different cases. Treat it like three different cases. So if my alternative hypothesis, if my null is something like mean is equals to some value, and if my alternate is mean less than some value or greater than that value or not equal to that value, and if I have given you the sample mean is given to us, and if I have given you the population standard deviation, which is sigma, if this is given, and if I have given you the sample mean, and I am checking with respect to mean, you have to use C test by considering test statistic to be x bar, and test will be something depending upon the alternative. Okay, test statistic will be x bar, and you convert this x bar minus mu naught by sigma by root n. This follows z. So you will convert this test statistic into this, and you will convert it into standard normal, and you will compute the values. So if I have given you the null, alternative, sample mean, and the population standard deviation. So if I have given you the population standard deviation, then you have to use Z test. Okay. Now there will be another case where I am testing the mean, and my alternative is the same, left tail or right tail. But here we will give you the sample mean and sample standard deviation, something like S square. So if we have given you this, okay, then we use t test by considering test statistic to be x bar and test as reject h naught based on alternative, and as I said x bar, now this test statistic I should convert to t distribution. So this x bar minus mu naught divided by s by root n. So okay, n is basically the number of samples. So this particular thing follows t distribution. Okay, the only difference between t distribution and z distribution is we know the population standard deviation here, but here it is population standard deviation we don't know, we know the sample standard deviation. So the only difference comes here. Sigma follows z distribution. If it is s in the denominator, it follows t distribution. So you have to use t test. So if these data is given to you, you have to follow t test. Or next thing is, so here we are dealing with only means. Okay.
Right,
Now
sir.
if I am dealing with standard deviation, so if my null is something like sigma is equals to sigma naught, and alternative is something like sigma is equals to sigma, okay, sigma greater than sigma naught, sigma less than sigma naught, sigma is equals to not equals to sigma naught, and we will give you sample standard deviation only. We don't worry about the sample mean here. We will give you the sample standard deviation. Okay. So if no sample mean is given, or even in the null and alternative, no mean, we are not testing on mean, then it will not relate to any t distribution or z distribution. It will relate to, if it is only one sample I have given you, it will relate to chi-square distribution. You have to use chi-square distribution here. So chi-square n minus 1 distribution. So where again n is the number of samples. Okay. So chi-square actually tests sample standard deviations. Okay. So what will be the test here? Test statistic here. So the test statistic will be S square. Okay. So variance. So we know test statistic. Now we have to convert this test statistic into chi-square distribution. So we know n minus 1 times S square by sigma naught square follows chi-square n minus 1 distribution. So you have to convert this test statistic into well-known distribution. So once, in order to fix this test statistic, you can fix it from the data given. So whatever the data we have given, we will be giving you only the number of samples and the sample standard deviation. With that, you will come up with the test statistic. So the test statistic will be S square and test will be depending upon the alternative. So you will reject H naught if S square is less than C square, S square is, so here test will be, for this it will be S square greater than C square. Here it will be S square less than C square. Here it will be mod of S square minus sigma naught square is greater than C square. Something like this. So you will reject H naught like this. So if it is, if we have given you, if we are testing on standard deviations and we have given you the sample standard deviation, you have to use chi-square distribution. Okay. So now you understand the difference between these three distributions. So here it is mean with population standard deviation given. Here it is mean, testing mean with sample standard deviation given. Here we are testing standard deviations where sample standard deviation is given. So that will be chi-square distribution. Okay. Now comes the fourth part. Fourth one is, yeah. Till now we have seen only one sample. So whatever the question, so whatever the data we give you, it is only, the data is only for one sample, one particular sample. So these are the only three tests we have for one sample. So from the data itself, if only one sample is given to you, then you no need to worry about this particular data follows some F distribution or some other distribution. It will follow either chi-square or T or Z. Only this distribution. Now when it comes to other thing, we will try to compare two samples means or compare two sample standard deviations. So null will be something like this. So when it comes to comparing means, so mu1 is equals to mu2, or alternative will be something like mu1 less than mu2 or mu1 greater than mu2 or mu1 is not equals to mu2. So in this case, what we will give you is, so we will give you sample 1 and sample 2. So not sample, we will give you two different samples. So first samples and the second samples. We will give you the mean, sample mean, which is x bar of first sample. We will give you the sample mean of second sample. And we will give you the standard deviation of first sample, not the first sample, standard deviation we will give you sigma, sigma 1 and sigma 2. So if we give you the standard deviations of the first samples, so this is the population standard deviation. So population standard deviation of first samples, population standard deviation of the second samples, and if we have given you the sample means for both the samples x bar and y bar, and we are testing for the mu1 and mu2. Mu1 and mu2. Okay, these mu1 and mu2 are the population mean of first distribution, first sample, and population mean of the second sample. If the data is even like this, so population standard deviations are given, then we will use F distribution. Okay. Okay. Yeah, here the test statistic will be mu1 minus, so x bar minus y bar. Okay, if the setup is like this, then we will use a F distribution. Just a second. Okay, sorry. Uh, yeah. So if this setup is given to you, two different samples and sample means is given to you, and the population standard deviations of both the distributions are given to you, samples are given to you, then you are checking for whether the sample means of both the samples are equal or it is less or greater. Or if this kind of if this kind of setup is given, we will use F distribution. So F distribution we will use only when it compares two different samples. Okay.
Sorry to interrupt over here, sir, but in question number 2, where we were comparing the similar kind of things in the case of social media time spent by men and women, right? So same situation was there, like we were having standard deviation for men and women differently, and we were comparing the mu of both, but we used the z distribution over there, no?
Okay, okay. We have used Z distribution, right?
Right.
Yeah, correct, correct. Sorry, sir. Sorry, yeah. Here we will use standard normal. See, yeah. Sorry, sorry. My bad. Sorry for that. Because see, this particular x bar minus y bar follows normal, right? Follows normal mu1 minus mu2 sigma 1 square by n1 plus sigma 2 n square by n2. So this follows normal. So when it follows normal, so this particular normal can be converted into standard normal directly by taking x bar minus y bar minus mu1 minus mu2 divided by under root of sigma 1 square by n1 plus sigma 2 square by n2. So this follows standard normal 0. Right? Yeah, sorry. This will not be F distribution. This will be Z distribution we use because we know the population standard deviations. So when you know the population standard deviations, you don't need to worry about whether it will be chi-square or whether it will be F distributions. Whenever you know the population standard deviations, we will use Z test. Okay.
Okay.
Yeah. So yeah, when you don't know the population standard deviations, then it will convert to the F distribution. See,
Okay.
usually, yeah, here we know the standard deviations, but whenever we are testing, the setup is like this. So there might be a setup like this. We are testing the standard deviations of two samples. So whether the standard deviation of both the samples are equal or not, or one standard deviation is greater or lesser or not equal to, and we will give you the standard deviation of first sample s1 square we will give you, and s2 square we will give you. So okay, sx square or sy square we will give you. So you know the variances of or the standard deviation of both the samples, and we wanted to check whether the population standard deviations are equal or one is greater or one is lesser. In this case, in this kind of cases, we will use F distribution. So in this F distribution, the test statistic will be Sx square by Sy square, or so depending upon the alternative, we will decide whether to take Sx square by Sy square or not. And yeah, depending upon the alternative only, we will define the test also. So where we will reject H naught. So we'll reject H naught if T is greater than 1 plus Cr or T is less than some 1 minus Cn. So this is how the test will be. So if we wanted to compare the standard deviations, if you wanted to test the standard deviations of two different samples, then we will use F distribution. Okay. Yeah, and there is again in lecture also, I guess, why we take this thing, not this thing. So why can't we take the test statistic to be X square minus Sy square? Because it is very easy to say. See, this particular X square by Sy square, we know this follows F distribution. So that is well-known distribution. But the distribution for Sx square minus Sy square is pretty difficult. So it is difficult to interpret. So that is why we take test statistic to be this. So you have to, if you are going to remember the things, then you should definitely remember the test statistic you are following. And you have to remember these things. So whenever population standard deviation is given, you have to use the Z test, Z test. So if the population standard deviation is not given, then it depends upon, if you are testing the mean, it will be T distribution. If you are testing the standard deviation, it will be chi-square distribution. So if one sample is given, if two samples are given, it will be F distribution. Okay. So depending upon, there are 5 cases. You can go back and see. These are the only 5 cases you will have. Okay.
Okay,
Okay.
sir.
I hope,
This
yeah,
info
just
is
go
much helpful.
back.
Yeah,
Yeah,
thank you
just
so
go
much.
back
It
and
was very helpful.
Sir, please upload this slide, this note in.
this one.
Yes, sir.
Yes, sir. It's much helpful
Yeah, this
than
is,
Helpful for us.
see, okay, I will do one thing. I will neatly
because
draw it like a table and I will upload. Okay.
right, sir.
Not
Because
like
to
this. This is
start any
ugly.
question, we need this information. Rest
Yeah,
calculation
yeah.
part is the later
Yeah,
thing, right?
right. Yeah,
I
yeah.
want to add one more to it. When in the 10th week graded assignment, they were asking for sum of the mean. That is also a little confusing. When to take X bar and when to take sum of the bar. It looks similar.
Yeah, see, if we have given you the test statistic, then that is different case. See, we have given you, if I have given you x1 plus and so on xn. So in order to convert this to standard normal, what I have to do? I have to
The
do
sum is given. It looks
t
not very
by,
similar. Okay.
so what I have to do is t by n minus mu by root over sigma by n. So ultimately I should convert this into mean. So after converting this into mean, minus mu by root over sigma by n follows the standard normal.
Okay. Because in the graded in the last week it was a little confusing. Sometimes we take X bar and it looks similar, but the binomial. So the formula varies, right? NP and so that's
Yeah.
confusing. Last week graded assignment.
Okay, graded assignment. Let me take a look at it. Graded assignment number.
I think the first
question is like average marks scored by a student of a
one
school in their board exams is reported to be 400 with a standard deviation of 5. Correct?
one second.
No,
I'm
I
just
don't
checking
think
the
this is correct.
problem.
Yeah.
And
Just
then
check and revert back. Yeah. Those who are asking this is ugly, man. You can't understand after this session. So I will try to come up with a table and I will upload within 2 days, 2 days of time, or maybe by tomorrow evening I will try to upload. So I will draw a table, like very neatly. I will draw the table. So where I will give you here, I will give you the description, data, and what distribution we should use, like this. Okay,
Yes,
that
sir.
will be very
That
easy.
so that information is much helpful to us actually to solve these kind of problems.
Yeah, yeah. So are you expecting that we should give this in
Include this one
final
in the
exam, or
formula sheet also.
Uh, if
see
possible,
for
sir, so that will be good.
see if we have given that, then the idea behind week 11 and week 10 will vanish off. So if you know what distribution to use, then we are testing you on only the calculation part. So that means it's very basic thing that we are testing you on, right? So who doesn't know when C is equals to 36.1 plus some 27.2? So adding these two numbers, everyone knows, right? Or comparing 36 is less than 35 or 36 greater than 35. So comparing that things are very easy afterwards. So
But
testing on that
that
doesn't
can be
give.
testing, sir, without giving some hypothesis, and we need to create the hypothesis by ourselves. So that testing can be done in that way as well. That which is the null hypothesis and which one is the alternate hypothesis. So because
Yeah.
the thing is that if we go in day-to-day life and we go into the statistics things, then these kind of hypotheses we need to create. But this information can be fetched from somewhere, some Google or something, that okay, which distribution need to be applied and how. But how the hypothesis need to be created, that is based on the problem statement only, and that is being
See,
done by
see.
ourselves only, right?
Correct, correct. Whatever you said is true. So even now I stick to my statement that when you are creating this null, when you are creating this alternate, is just a matter of seeing the data. So viewing the data and understanding the data. Correct.
Exactly, sir.
So once you
Exactly, sir.
understand the data, you will definitely no need to say. You will directly, yeah, this is, yeah, I know the population standard deviation. There are two samples. Yeah, I'm comparing the mean, so I should use C test. Okay, once you understand the data, you will automatically get to know. Yeah, okay. What I suggest you is just go through few more examples and understand where, in what scenarios we are using which tests. Also, I will provide this table. You have 1 week. Just understand. You solve the problem. If you are unable to solve by your own, just come back to this table and see, map them. Just see what distribution you should use, and you go back. And I
Yeah.
strongly recommend when it comes to week 11, 10, don't uh, we intend to see the solution straight away than solving it. So don't do that. Whenever you are doing tutorial problems or when it comes to practice assignment questions, so try until you are vexed of that question. Like try for at least hours, so 2 3 hours. Not at this moment. I don't suggest now, but it should have been done very early. So then you might have got an understanding week 10 and 11. So yeah, now also I suggest you try for try it by yourself. If you are unable to get, then only just move to the solution part, or friends help or anywhere. Okay, try to understand the question first.
Sure,
Once
sir.
you understand the question, it's a matter of solving. That's it.
Week 10, 4 and 5, it looks very similar. Can you just explain, just to give a hint? In one of the problem, we are taking sums, and one we are taking only x bar, but both are binomial. So I don't know. I can understand.
Week 10, question
Graded
number
assignment 4 and 5.
4 and 5. I am seeing like let x1 to x100 be a sample from a normal distribution having a variance of 25. Am I looking the wrong assignment? Is this the question? Okay, anyway, I will come to you. Rest of the guys, you can leave. I am done. So I will upload, and it's already 9:30. Okay.
Yeah, thank you, sir. Thank
Okay,
you very
I
much.
will share the solutions also. I will try to share the solutions of week 10. I will ask them to upload that. So yeah.
Yes, sir.
Okay, thank you. Thank you so much for joining, and have a good day.
Thank you, sir. Thank you very much.
Yeah, those who have doubts, just hold on for 10 minutes. We will wrap up at within 9:45. Okay. Yeah. Uma or Usha,
Sorry,
if
6 and
yeah,
7. Sorry, numbers 6 and
yeah.
7.
Okay. Okay. 6 and 7 is a manufacturer supplies fuses,
Yeah,
approximately 90% of which function properly. A
yes.
new process is initiated. Okay, let me share the screen also. Yeah, this is a question, right? A
Yes,
manufacturer
yes, yeah.
supplies. Okay. Now you see,
I
he
think
said
6
the
and 8.
manufacturer supplies, yeah, 6 and
8 that both problems look binomial, but the one we are taking, that's where my doubt is. Yeah.
okay, okay. So see here, we are the data says that there is a manufacturer who supplies fuses, approximately 90% of which functions properly.
Yeah.
Okay. So here it says the direct value is given to you. Okay, that means
Yes.
this falls under null. And the second statement says that a new process is initiated whose purpose is to increase. Yeah, the synonym of large, big, huge, increase, greater, these
So
kind of
alternate.
things alternate.
Okay.
So a new process is initiated whose purpose is to increase the proportion of properly functioning fuses. That means the probability that my fuse works, initially
Yeah.
it is 0.9, but for the new process, I need to increase my probability of success. That means I need to have P should be greater than 0.9.
0.9. Yeah.
Yeah. Now we obtain a random sample of 100 such fuses manufactured by new process and found out that 8 of them are not functioning properly. Okay. Now let P be denotes the proportion of properly functioning fuses. Use normal approximation to binomial. Okay, here
Oh,
we
okay.
have binomial distribution. Okay, we
Okay.
have 100 samples. And what is the expected value or the mu when we are approximating it to normal? Okay, I got the question here. Let me go back to my journal screen. Okay. See my distribution, I have 100 samples out of which 8 doesn't function and 92 function proper. Correct? So if I
Yeah.
have 100 samples which are binomial 100 comma P, correct?
Yeah.
Now if I wanted to approximate to normal, I need mu and I need variance. So what is the expected, mu is nothing but the expected value of this. What is the expected value of binomial 100 comma P?
It's P, 100p.
Correct. 100. What is the variance?
100p into 1 minus p.
Correct. Right. Now I have mean, I have variance, so I can approximate this to normal mean sigma square, which will be normal 100p comma 100p times 1 minus p. Okay. Yeah. Now I have my test statistic can be anything. I don't worry. But if I take test statistic to be like this, then T by n minus mu by root over sigma square by n follows normal 0. Okay. If I have taken T to be x1 plus and so on, or the mean of the 100 samples, which is x bar. If I have taken like this, then x bar minus mu by root over sigma square by n follows normal 0. Okay. Here I have x bar, and that x bar minus mu by root over sigma square by n follows standard norm. But here my test static is sum. So in order to convert to the mean, I will just divide the test statistic by n. So now this becomes x bar. The same thing, x bar minus mu by root over sigma square by n.
But in the question, I'm just not understanding how you took x1 to, there's no clue to take the t as x1 up to x100, right? In generally, it looks like all similar problems, but here suddenly we're taking some. I don't know how.
Okay.
That's where I'm not
See,
getting.
Okay. Why we are taking sum is
Usually
because
take the
when
variable x bar, right? We don't go to the sum.
Right. But you
That's
see
where I'm
here,
not
if you
getting.
understand, yeah, correct. So if you see here, we are testing. So this takes either 0 or 1, like whether this fails or this passes.
The nullity, and this is binomial. Yeah, that I got it.
Yeah, this will be binomial. Correct. So if I think about mean, what is mean actually?
Yeah, that's some
what
of
will be
the
the mean?
samples. Yeah, some of the samples.
Yeah, sum of the samples divided by 100.
Yeah.
So if I say 90 samples are functioning correctly and 10 samples failed, that means this x1 to x100 will be 90 by 100. Correct? What this mean gives me? This mean gives me the proportion of number of success fuses, right?
Yes.
Mean is basically the number of, mean actually the expected value, expected number of fuses passes. So that mean is actually 0.9. So when I consider the sum, what will be the sum denote?
It will be that n into x bar, right? Yeah.
What is the sum? See, this denotes me the proportion of success.
Yeah.
Success or successful fuses. So this 90 is number of successful fuses. Correct? This is the number of successful fuses. This is the proportion of successful fuses. Understand the difference between the proportion and the number.
Okay. So the question, what is asked and why we are taking, because of it's asked for number of. Can you just go back to question and explain?
Yeah. So now let's come back to the question. So here we are talking about the proportion.
Okay.
Correct? Here we are talking about 90% of is functioning properly, and we are talking about the proportion. So here you should take T to be mean. Okay. When it comes to here, a commonly prescribed drug for relieving nervous tension is believed to be only 25% effective. To determine if a new drug is superior in providing. Okay. So what is the difference here? I don't see any difference. You can take
here. Do we take x bar or some that the same binomial here also? So because the sigma varies, right? If we take sum and the x bar, the sigma will completely vary when you substitute. That's where the problem will be wrong, right?
Sigma varies.
No, for sum it is 100p into, it's different, right? And for x bar it's only 100. You come up with the way sigma varies for the two of the problems. That's where I was confused. Anyway, first problem correct. I will just write it in discourse if you want. A second problem, I'm not getting it. That's
Venkatesh, sorry to interrupt. Actually, there is a power cut and just 5 minutes of battery is left.
Okay. Sorry. I will just come back to you.
Okay,
If
maybe you
you
can go ahead. Yeah, I just need this
Yeah.
if
solution
you
is
I
don't
will
provided.
just
mind,
come.
Uma. Yeah.
Yeah, thanks.
Okay. Let me
Thanks.
go to week 9 tutorial 1. So you are worried about X and lambda, right? I have just gone through
Yeah.
that.
So exactly, I mean, when lambda is considered as a constant, right? And then we are taking the same x to be lambda. That's what is just causing confusion.
Even there also,
So
X is
in gamma
constant.
distribution, right? Gamma, okay. But how can x be a constant?
See, here we are.
Hi, Venkatesh. Cannot hear you.
He got disconnected, I
Oh,
think.
okay.
Okay. Sorry. Or Apple is there here? He left, is it? Okay. Sorry. Again, I was locked out suddenly. I don't know why this is happening. Am I audible?
Yes.
Yeah. Okay, I lost this this thing also. Okay. Uma, can you try that sixth question by taking test statistic to be
Okay. Yeah, I'll try this
the
and
mean
I'll
itself?
try this course. Yeah.
Yeah. Try
Right.
taking the test statistic to be mean, and if you are
Okay.
unable to come up to the conclusion, then just post it in the discourse.
Okay. I just got confused. Okay. Yeah, I'll try with the X bar.
Yeah. Okay.
Thanks a
Okay.
lot.
Okay.
Pritesh.
Yeah.
Thank
Yeah.
you
Okay. Then.
so
Yeah.
much.
We will meet again. Okay. Thanks a lot, and have a good.